I would like to welcome you to the first VMware Code Connect event on day 2, and especially to my session of the event. The subject of my session is about how you could fully automate the creation of an app volumes for application package. My name is Sidney Laan. I'm living in the Netherlands, and I have a passion for IT since my childhood. Around 2010, I have my focus on desktop and application virtualization from vendors like Ivanti and Citrix. But last 4 years, this changed to VMware products like Horizon, App Volumes, Dynamic Environment Manager, and Workspace ONE. Currently, I work as a virtualization consultant at a VMware partner in the Netherlands called ITQ. Do you like to work from a working procedure document day in, day out? I don't, and that's why I started creating scripts. You can follow me on LinkedIn, Twitter, or bookmark my blog. This year, I achieved the VMware vExpert and vExpert EUC subprogram status for the first time. My session will include the following topics: app volumes in general, why do we use it, biggest difference between app volumes 2 and 4, and focus on the capturing process. Why should we automate this process? What was my use case, and which tools and scripting languages did I use? Before you can run my code, there are some prerequisites which needs to be in place. In sequence, I explain the code and focus on the parts which really matters. After the explanation, I will demonstrate my code within my home lab. Don't leave after that because I have some key takeaways. App volumes is meant for application layering and intended for closing the gap between installing your application on the operating system and a virtual application sandbox like VMware TinApp. Not every application supports to run in a sandbox. A disadvantage of installing applications on your operating system is, for example, an application that has limited numbers of licenses or a company critical application that not everyone is allowed to start. So with app volumes, you can bundle applications that become seamless with the operating system, and only authorized users get these applications. A good example could be that you create an app stack based on departments or functions inside your organization. A bundle of applications is called an app stack, which is a read-only VMDK file within vSphere. Then you have a writable volume, which is a personal piece of storage for the users. This could include roaming profiles or Outlook cache files or applications that are not managed by your IT department. Recently, it has also been possible to offer app stacks in public cloud solutions such as VMware Horizon servers on Microsoft Azure and VMware Cloud on AWS. On the right side of the slide, you see the components of app volumes. Components which I used for my automations are the VM with app volumes agent, packages, app volumes manager server, and the vCenter server. When you work for a customer that wants or has app volumes too, there are still some 3 important things to keep in mind. The limitation of app volumes 2 is attaching 5 or more app stacks, because this has a serious impact on the logon times. The customer must know this application landscape very well in order to be able to correct app stack formats, so that an application does not end up in multiple app stacks. When using writable volumes and you have a multi-data center setup, you're short bound to only one data center with your virtual desktop session. Unfortunately, writable volumes cannot be synchronized across multiple data centers. Where we need to bundle application in app volumes to app stacks, this doesn't apply any longer in app volumes 4. There we go to a so-called application package. The limitation of assigning at most 5 app stacks to one user is not longer in version 4. VMware redeveloped this part of app volumes. A best practice has not been set yet, but you can easily assign up to 15 application packages to a user without a logon performance penalty. An application package consists of one application, including prerequisites. You will start with the creation of an application, and this application can consist of several application packages. You can think of, for example, Notepad++. The application Notepad++ and the multiple packages can be versions like 7.8.7 or 7.8.8, etc. Keep in mind, when using AppVolumes4, there's a limit to the number of virtual hard drives that can be connected to the disk controller. If you have over more than 14 application packages assigned to a user, you need to add a second disk controller. Once the infrastructure is in place, installed and configured, we can zoom into the capturing process of an application package. First, you need to log on to the AppVolumes4 admin console. There you can create an application, and there's an option in the wizard to create immediately the application package, which is based on the abstract template. A copy is made from that template. Take care that you have a virtual machine in place that is almost identical to your virtual desktop image or your remote desktop server image. Log in to the so-called capture VM and perform some tasks which must not be captured, like copying installers or connect to a network drive. Assign the application package to be created to the capture machine via the admin console. A pop-up will now appear in the capture virtual machine with the message that all changes will now be written to the application package, so it's in a write mode. Install the application that should come into the application package and reboot if required. Perform some post-installation tasks, like adding registry keys or computer-based configuration files, so that auto-updates of applications are disabled. Once you are done with all your necessary things, you can click the OK button in the AppVolumes capture window. There will be a reboot of the capture virtual machine and the reboot is complete. You can log back in and you will see that it's ready and has converted to a read-only status. Revert your AppVolumes capture VM back to a clean state. If you have multiple data centers set up, then you can wait for the storage replication to happen or start the replication manually. Then you have three options to get the newly created application package to the users. These are user-based, group-based, or OU-based. Why do we want to automate this capturing process of an application? Now, in my opinion, there are several reasons, and these are my most important ones. Avoid human errors and misunderstandings from manuals. Not the same level of knowledge within an application packaging team. It reduces the application package time. It reduces the amount of manual clicks. And at last, reinventing the wheel over and over again. This code project started as a hobby because of AppVolumes4 was launched at the beginning of this year. The automation interest started because I just completed a packaging project at a large cancer hospital and was in between projects. So I could spend some time to make this work. On the VMware code site, I found a REST API document about AppVolumes, but it was only based on AppVolumes2, so I needed to figure out all the REST API commands by myself. I knew a little bit of Postman and was familiar with PowerShell scripting, so I decided to use this to start. On the other hand, I needed to talk to VMware vCenter to start and stop my AppVolumes capture virtual machine and revert it back to a clean snapshot, so PowerCLI needed to be used for this. I wrote out the capturing process steps, which I described in the previous slide, and then create the code per action. For example, connect to the AppVolumes REST API, create applications via REST API, etc., etc. When the sequence was right, I was able to implement error handling, logging, and make the output and script more user-friendly. Because I was in between projects and we didn't have any customers with AppVolumes4 yet, I set everything up in my home lab. The nice thing of this is you don't have any limitations or lack of permissions. During the build, I got assigned to a new project where the main goal was upgrading the EUC environment, including AppVolumes4. Here I saw a nice opportunity and asked the project manager to work on it. Not only the project manager picked it up, but also the managed services owner, and sees this also as a good use case for having this in the MSP for customers. Before you can successfully run my code, there's a list of prerequisites. At first, you need VMware PowerCLI installed on your computer and have the ability to communicate to VMware vCenter, server, and App Volumes managers. Also, you need an Active Directory Service account, which will be used to auto-log on to Windows and will be marked as App Volumes application owner. This account needs to be full administrator within App Volumes, and you can create a custom role with the necessary vCenter permissions. And at last, share permissions on the software repository. A virtual machine, which is almost a copy of your VDI or RDS host, and have some computer group policies applied. For example, maximum machine account password age or Windows remote management servers, and add the packaging service account to the built-in local administrators group. Adjust at last the static variables in my script to meet your requirements from your environment. Just before running the code, you need to bypass the execution policy of PowerShell because your unwritten code is not by default signed. This is my code step by step. Pity enough, I cannot make the code public available upon the request of my employer, but I can explain how my code looks like and how the most important parts are. Like every script, you need to set variables. I've chosen to have a static part, which mostly changes once in your environment. The other variable part is the dynamic part, which you need to adjust for every new application you need to package. After that, I start logging the output to a text file. Next step is importing the VMware PowerCLI module, which can interact with the virtual machines. Power on, power off, and revert the snapshot to a clean state. The functions section in my script, I wanted a better user experience and have a progress bar in the PowerShell window. Start with setting up a REST API session to your App Volumes Manager, so you can do get, but also post commands to it. I can do it with this command. This section, I put one of the last things in my script because I found out that the first user in Active Directory was owner of the application within App Volumes. So what I do with this part is using a get command to retrieve the Active Directory service account object GUID and store it in a variable. Then you can use it in the next section, where I'm running an API post command to create an application within App Volumes. Working with PowerShell and REST APIs, you mainly use the invoke REST method or invoke web request function. You also might think, how do I know this values inside the URI? That secret I can tell you. Use a browser and open the developer tools with F12. Do your action in the App Volumes admin console and go to the network tab in the developer tools and look up for the post commands. Select it and then check the header and the params page on the right. This time we run the API post command with different parameters inside the URI so we can create an application package. You need here a lot of parameters to get it right in App Volumes. The first part, what you normally do in the App Volumes admin console, is done. The next 3 steps, we need to prepare the App Volumes capture VM. First, by setting up a PowerCLI vCenter server connection, followed by reverting the App Volumes capture VM to a clean state snapshot, and then power it on. Opening a VMware console is a default function in PowerCLI by calling the Open VM Console Window command. Because I make use of remote PowerShell commands, there is not an option to run the installers from the network share, also known as the double hop. That's why I copy the installers to an App Volumes capture VM with the simple copy item PowerShell command. Before we can make use of the remote PowerShell commands, the Windows Remote Management Server must run on the App Volumes capture VM. Therefore, I use a do until command to check till the service is running. From now on till the next reboot, I can establish a remote PowerShell session with the following commands. In the last phase of the script, we need to bring the app volumes capture window to the foreground, and we need to simulate the enter or space key to hit the OK button a couple of times. I did this trick with a locally created PowerShell script. Here you can see the actions. The first part, what you normally do in the app volumes admin console. Now we create a scheduled task without a trigger based on running the local script I have created in the previous step. But don't run it yet. Now we are almost done with starting the installation, but we need to assign the app volumes application package to the app volumes capture VM. Before we can do that, we need to execute an API get command to retrieve the app volumes VM ID and UUID and store it in a variable. The API get command queries the list of virtual machines with the app volumes agent installed, but the filter on the app volumes capture machine VM name, which matches the app volumes capture VM name from the variables, and if it's active in app volumes. And we also need the app volumes application package ID, so we can bring them both together. The API get command queries the lists the application package and filter on the application package name we set in the PowerShell variable. Only one entry will be there, so we can store the ID in a separate variable. Now we use REST post commands to attach the application package to the app volumes capture VM and start the actual capturing. From now on, every change will be saved inside the application package. Within the URI, you need the application package ID, app volumes capture VM ID, and the app volumes capture VM UUID. There are many ways to install an application, but I wanted to use remote PowerShell commands to silently install different types of installers. The script section, how I did that is too long for this session, but like I said, there are multiple ways to do it. After the installer returns a successful exit code, I gave my script a couple of examples. And this could be disabling auto updates with the Windows registry and language files to installation directory and removing the start menu and desktop shortcuts. If the installer returns a 3010, the script will initiate a reboot and wait till the Windows management service is running again. When all steps are executed, we can tell app volumes via the app volumes capture window to complete the application package. Now it's time to run the scheduled task we created earlier on the script. At the last OK, the virtual machine will reboot and deattach from the app volumes capture machine. The app volumes capture VM can be reverted to a clean snapshot again. We can close the VMware remote console if not already closed, and then stop the logging process and exit PowerShell. Now it's demo time. What I just described, you can now see in action. I've prepared my home lab with all the necessary things. What we now do is capture the installation in an app volumes 4 package of the application called Earphone View. That's a photo viewer. So we need to execute these 2 lines to bypass the execution policy and go to the script directory where my script is. Then I will need to execute the script. I need to enter the service account from the packaging user. I hit enter. Now it started logging, trying to import the PowerCLI modules from the for starting and stopping the VM. It's connecting to the app volumes REST API, create an app volumes 4 application package. As you can see here, it's created now. And also step 2, creating application package. You can see it here. It's still in package because it's not attached to the app volumes capture machine yet. Now it's connecting to VMware vCenter via PowerCLI, reverting the snapshot back, powering on a virtual machine, the application packaging machine. And it opened the VMware vSphere remote console. Now it's copying the installer files to this machine and this location, because this location isn't captured by app volumes. Then it's checking if the Windows Remote Management Service is running to do remote PowerShell. And from now on, everything will be captured. You see the app volumes application package window. Now it's starting the installation. It exits successful with an exit code 0. And it does the post configuration steps. In Ervan view is this the Dutch language pack. And now, like I described, I simulate the enter or spacebar keys to hit this OK button 5 times, I think. And between this one and the next one is a little bit longer, because when you have prerequisite software, it can be that the name is different here, that it's, for example, Visual C++. So you can change it by hand if it's necessary, but most of the times it's correct. Okay, it's now done. It will be reboot automatically. So they can detach the application package from the capture machine. With variables, for example, you can change the startup time of your capture machine. In my home lab, it's about 40 seconds. As you can see, the package creation is now successful, and this virtual machine will be reverted to a clean snapshot. The window is closed and the logging is stopped. As you can see here in the console, it's enabled. It's 167 MBs, and everything seems to be fine. In App Volumes 4, you assign the package of the application up here. I've pre-created the groups already in Active Directory. I select the groups which I'm a member of and the application package and not the marker, because then you can change the test or the production group to a different package. Now I assign it, and let's have a look if everything works out and if I get the application package attached. Still not correct. Yeah, here it goes. This is a Windows 10 VDI, which now automatically will get the App Volumes application package attached. Here you have in front view, and we can also see it did the post configuration steps by using the Dutch language pack. Okay, this was my demo. I hope you enjoyed it. Now I have some key takeaways, and hope you're motivated to create your own App Volumes application package script. So the takeaways: it is not possible to perform a direct upgrade from App Volumes 2.17 to App Volumes 4. So first you need to upgrade to 2.18. the AppVolumes4 agent does not work with AppVolumes2 AppStacks, and you should therefore continue to use the 2.x AppVolumes agent. The AppVolumes2 agent cannot handle application packages created in AppVolumes4. In other words, not backwards compatible. Then I want to mention that there is a VMware Fling that converts AppVolumes4 AppStacks to AppVolumes4 application packages. That is called the application migration utility. And before you're running PowerShell commands with API calls, do your API call with Postman. And mentioned earlier, find your API calls via the developer tools from your internet browser. I prefer Mozilla Firefox. If you have any questions about my code after the session, don't hesitate to send me a DM on Twitter or LinkedIn, and don't forget to bookmark my blog. Thank you for watching and have a great event. Are there any questions?
We've got one in the Q&A right now
Yeah.
from Thomas. It's just, will your code samples also be available?
Yeah, the samples in the sheet I can make public available, but not script.
All right, thank you. If anyone else has any other questions, we have a few minutes. Feel free to ask them in chat or in the Q&A form, but we're here until 1:30. And also, I posted in the chat a survey. If you could please fill out that survey. It's just all of that feedback helps us with future conferences like this one. So please use that link and fill out the form if you can. Spare a couple minutes, but appreciate it, everyone. So if you have any